Hello, in this video I will show how to use 4-axis continuous milling in CÂNG. We will machine the part that you can see on the screen. At the first step I would like to locate my part in the coordinate system. So it is imported and we need to x-axis, y-axis, we need to rotate it. So to do it, select the part, click transform, rotate around x-axis 19 degrees, apply. The next step, locate 0 and locate 0 middle x, middle y, middle min z. Okay, so right now our part is located this way, so the rotary axis is located along z-axis. Next step, go to machining and choose the machine. So we can see the machine right now. The part is located on the table. Next step, I would like to define the workpiece. To do it, I will choose machine, select workpiece, define primitive, and create turn envelope around z-axis. Add this kind of, so and close. Right now we can see machine. I will make the machine invisible and we can see the workpiece. So workpiece is transparent. Okay, so we would like to remove this material. I recommend to do it, I recommend to use rotary operation. Creating the rotary operation, create, finishing, rotary machining, create. The new operation appeared in operation list. So the first step for the rotary operation, I have to define the rotary axis. Rotary axis can be defined on this page. Rotary axis orientation. We can define the global coordinate system. This is the coordinate system that we can see here. Okay, and along z-axis. Nice. Make machine visible. So I define only it, tool is defined automatically. I can run calculation. The calculation needs some times, I think maybe 1 minute. Well, so toolpath is calculated. After that, go into simulation mode and start simulation. Make the part, one moment, make the part visible this way, so our workpiece is visible. And start simulation again. So this way we can take our part. So let's have a look on the parameters of rotary machining. At the first step, I would like to define the zone I would like to machine. It is better to define the job assignment. and I reset the toolpath, make machine invisible, make workpiece invisible, and after that I would like to machine only the parts, these surfaces. To do it, I select, one moment, I select all these surfaces, not a problem. I uncheck this button to select faces separately, select everything, and after that hold Ctrl and unselect inner faces. Yes, this one. So only outer faces are selected, and after that I add the selected faces to the job assignment. Click this button. So only these faces will be machined. The next step, I would like to change the strategy of machining. Click parameters, go on strategy, and toolpath form change to linear, and the step, and I would like to make the tool smaller, and for example this one, and define the holder. Okay, nice. Calculate the toolpath. Waiting about some seconds again. So now we can see that only selected faces are machined and nothing more. Let's have a look in simulation. Very good. I reset the workpiece state, and we can see that the toolpath is going on the place that changed nothing. Yes, I don't want to go along these surfaces because it remove nothing. So to choose it, to remove this toolpath, I need to check the workpiece. Well, go to machining back and go to parameters, trimming toolpath, and define check workpiece. This is the value distance from the workpiece to the pad that will be ignored. I will set, for example, 5 here and click OK. Recalculate the toolpath. So right now we check the workpiece. It takes more time for the calculation, but calculation is still quite fast. Well, we can see that the toolpath is located in the place the workpiece exists. go to simulation, have a look, reset the workpiece and calculate and simulate. At the speed. So right now it removes all the place. Let's have a look on this. Sometimes it makes the lines and after that go back. Well, so make toolpath invisible, make machine invisible, and have a look on the result. Very good. And I have some error messages. Click right mouse button and go to next error. Yes. And what is the message? Let's make the toolpath visible. It says that we have a contact with toolpath on the rapid speed. So to remove this problem, I need to define lead in, lead out, and define step level. One moment. Okay, so the toolpath is not very clear here. To resolve this problem, I recommend, for example, go to strategy and disable the optimization. Recalculating the toolpath. Okay, right now toolpath is not so optimal, but it is quite clear. Let's reset the workpiece and make machine visible. And start the simulation. Toolpath is not so optimal, but it is clear. Okay. So we can see that there is no mistakes. Well, it is not all for this operation. We can see that the depth of the milling is quite big here. I go to model and double click on this face. The radius of this fillet is about 9 millimeters, so the depth of this slot is about 9 millimeters. In this place the depth of the slot is about 14 millimeters. This height is too big for the milling, so it could be fine to define the rough passes. To do it, go to machining and define the parameters and radial layers, add the rough passes. 14 millimeters is the depth, and for example I would like to make 4 layers. Okay, click OK and recalculate the toolpath. So it takes 4 times more time for the calculation. Maybe not so. Waiting. Well, waiting for the result. The calculation time is about 2 minutes. Okay, so go to simulation and let's have a look on the toolpath. Toolpath have 4 levels. Make the workpiece invisible and the part visible. First layer, second layer, third layer and the last layer. Okay, the depth of the milling is equal, not more than this distance. Okay, we can have a look on the simulation, reset and play again. make the workpiece visible, make the part invisible. Second layer, and the third layer, and the last layer. Okay, right now I've shown you one way how to machine the how to make 4-axis continuous milling with extrude at the next part of I will show how to make the toolpath along the slots. Thank you for your attention.